And so I'm not very good with technology. All right, I'll try to remember. I'm recording now, so right now when you go online to the YouTube thing, you'll get this. You probably won't even need to with these early ones. All right, here we go. Here's our formula. A equals a half BH. They're basically saying take that formula and plug in B is 16, H is 18. So feel free to write down what you can, but like I said, later this will all be available on the YouTube channel if you miss it. So this is question, notice up here, this is question number 1. This is exactly how your question will be. In fact, it'll even be the same formula. They'll just give you a different value for B. They might give you 10, and H might be 12 or something. But it's going to be the exact same words, exact same formula when you do question 1 on 1.1. All right, so how do we do that? What is it they want me to do here? Yeah, they want me to stick this, basically plug that B in there and plug that H in there. It's just a plug-in deal, huh? Are you aware when you plug into math formulas, you want to put parentheses around the things you're plugging in? So let's do that. So A equals a half. The B is kind of messed up now. The B is 16, and the H is 18. Okay, so a half. Now, those parentheses mean times, don't they? And that's what the original formula meant. How do I know? Well, because there was no plus sign or minus sign between the half and the B. And there was nothing between the B and the H. When there's nothing between two items, that means times, doesn't it? So this is times. Now, you can use calculators, homework, tests, everything. So you can just type this in on your calculator if you want. Here's what I would type on the calculator. 1 divided by 2, because that's what a fraction. Fraction means divide. You can just literally go 1 divided by 2 times 16 times 18. Oops. And that has some kind of answer. 80 and 40.
On my Math Excel, it says B equals 19, H equals 20.
Yeah, same thing, the same formula, right?
Okay, yeah.
Yeah, so you just plug in whatever numbers you have. Yeah, you can feel free to do your homework as we go. So somebody got that in there? What is it, 80 and 48?
144.
Is it? 8 times 8, 80. Oh, 144. You're right. Of course, I should test the calculator. You're right. 144. Yeah, 144. You'll have different numbers when you do it. And there we go. Is that good on that? So I'm just doing your homework. I won't do them all. So I'm going to get that off. You may or might not have copied all that down, but like I said, so everything I just said was not on. All right. Anyway, whatever. Let's go to the screenshot there. All right. So there's the question. Can you all see that? Okay. So there's our question, and 8p over g. That's not very big. Let me write it right here a little bigger. Okay, and they're telling me P is 16, G is 8. So we just plug them in, right? So we get, and put parentheses when you plug into a math formula. The P, the G, and then, you could use a calculator if you want, just 8 times 16 divided by 8, but probably most of you know what the answer is going to be already, huh? Yeah, exactly. You can just cancel those 8s. The answer is just a straight 16. The calculator would tell you the same thing. On that. Good enough on those so far? Okay, I'll keep moving. Again, if you don't get... All right, so can you all see that okay? It's negative 19. And then a 16, and then in the middle, it wants me to put like a greater than, less than symbol. So do you remember how that symbol works? Right? It's basically it's gonna go this way, and the reason is because the narrow side is the smaller, and the wide mouth side is always the bigger item. Right? So it's like, the old alligator analogy, right? The wide mouth side is the bigger item. The narrow side is the smaller item. And negative 19 is smaller. Why? Well, because it's negative, huh? Right? Just think financially. That's called being in debt. We all been there. I live half my life there with 5 kids. right? Negative is in debt. That's worse off than being 16 positive, right? Good? We good there? All right. So, okay, so guess what I'm going to do with a couple of fractions. So they got negative 2/3, and they got negative 4/6. What am I going to do with a couple of fractions to make them easier to deal with? You could reduce them. Yeah, that's a good observation. You can reduce, this one, probably a lot of you guys recognize, that's the same thing, huh? If you reduce that, that's 2/3. So these are actually equal, aren't they? And that's great. If you're comfortable with fractions, you know that. Feel free to do that. If they give you like totally weird fractions, like negative 2/3 and negative 3/7 or some kind of weird fraction, I would just divide them both on my calculator to make them a decimal, and then I can easily tell which one's bigger or smaller. So I'm just giving you a couple options. So I would probably divide on my calculator 2 divided by 3, and it would be, and it's negative, 0.666 forever. And that goes on and on and on. And then I would take 4 divided by 6 on my calculator, and that is the same exact thing. 6 is forever. And it is also negative. And then I would say, oh, okay, they're equal. So that's the answer. But you probably already knew that just by looking, that's fine. Yeah?
Isn't it easier just to cross multiply?
Oh, you can do the cross multiply thing, yeah. Did you have this Bazarian?
I did not.
She teaches the cross multiply thing. It's a good way to go. Yeah, the heart method, right? The heart method. Yes. Yeah. I recognize the method. Yeah, that'll work great. That'll work great too. Good with that? On that? Okay, so let's take a look at this one. So it says 20 and then greater than b like that. And then they tell me they want me to rewrite it. They say the inequality has the same meaning as, they want me to rewrite it like a different way. Same meaning as. So how else can I say that same truth? Meaning, what they're saying, it's a little weird how they're saying it. They want the b to be on the left, and they want the 20 to be on the right, yet the same truth to be conveyed. So how do you say the same truth in the opposite order, with the b coming first? Just flip the symbol. Right, yeah. You all realize that says exactly the same thing, doesn't it? In both cases, notice it says b is the smaller one, doesn't it? Right? B is on the narrow side, smaller. 20, it's a funny looking E there. At 20 is on the wide side, so it's larger. Right? Same thing here. B is on the narrow side. B is smaller. And 20 is on the larger side, on the wide side. So 20 is larger. Same truth. B is smaller than 20. Said either way. So notice that then it's important to, So notice you can read it left to right, but it says 20 greater than B, which is the same thing as B is smaller than 20. You can read them left to right or right to left. And the meaning is still the same, isn't it? 20 is the bigger one. B is the smaller one. Either way you read it. That's all they want on that. All right, so absolute value of negative 12/5. What do absolute values do? What do those straight bars do? Make it positive and vanish. So they'll vanish, and the minus sign will vanish, and it'll just be 12/5. That's a funny looking 12. Try again there. 12/5. That's all they want. You don't even have to turn it into a decimal or divide it or do anything. All they want is you to do the absolute value thing, which makes it positive, and then they vanish after they do their job. A lot of students will leave the absolute values hanging on. They'll be a little confused by that, so let me say that again one more time. When the absolute values make it positive, they then exit. They leave. They don't stay there. When they do their job, then they leave. They just make it positive and they leave. Is that good? 2 sections down. Okay, so 6 minus 7. What's the deal? Do you remember this from earlier math stuff? What do you do? What happens there with those signs? Yeah, these two signs right here, these two negatives become positive, don't they? Right? It's not writing very well. 2 negatives next to each other become positive. All right, so 2 negatives next to each other become positive, don't they? And then it's just 13. Why isn't it multiply? I thought parentheses always mean multiply. Why didn't we multiply there?
You are pretty much, but you just can't see the one in front of the...
Right, you could always count there at 1. But I mean, why didn't I multiply 6 with 7 and get 42?
Because there's the minus in the middle.
Yeah, so when, that's right, because there was another symbol in the middle, it doesn't really mean multiply. So parentheses do not always mean multiply. When do they mean multiply? When they're right next to each other, when there's nothing else in the middle, right? So if we had something like 6 parentheses 7 with no symbol in the middle, that would mean 42. That would mean times. That's a different deal, right? When there's another symbol in the middle, like there is here, then it's not multiply, even though there's parentheses. So parentheses do not always mean multiply, do they? Only when there's no other symbol between. There's some other symbol, adding or subtracting, but then it's an adding and subtracting deal. It's not a multiply. Is that good? So 2 negatives right next to each other, both become positive. And then we just wrap it up with adding. 13 it is. All right, let's move on from there. All right, so there it is. So it's negative 8 minus negative 7. All right, so the first step, the 2 negatives become positive, right? And I mean these two. The two that are head to head, the two that are right next to each other, huh? So then the negative on the 8 stays there, but the other two become positive. We good with that? Kind of getting scribbly there. So that's the first step. So 2 negatives head to head, make them positive. And then what's the answer to that now?
Negative 15.
Yeah, it's going to be negative 1. Let me show you let me help with that. You can do a number line if it helps you. You don't need to. You can use calculator too. But basically what it says, here's 0, and it says, look, you're at negative 8, and you go 7 to the right. You add 7. Where do you end up? Negative 1, huh? So start at negative 8. Add, go to the right, 7, you end up at negative 1. Yeah, so I think the easiest thing to do is just think about, it's football season, the playoffs are on, right? Gains and losses, right? If the football team on the first play loses 8 yards and then gains back 7, what's the net result? They lost a yard. Huh? So I think if you just think gains and losses, you'll know exactly what to do. Rather than me giving you fancy rules, if you read the book, they'll say, you can access the book, by the way, through the help button as well. If you read the book, it'll say, well, if they're the same sign, you add them. If they're different signs, it's a subtraction. That's true, but I don't know. All those rules, you can forget those so easily. I think it's more sensible just to think, well, real life. What happens if a football team loses 8 yards, they fall back 8 yards, and the next play they gain 7? Where are they at? They're back a yard. Or money. If I lose $8, later I gain 7, where's my bank account? Still down $1, right? Good, so just think gains and losses. But first, I did the two negatives head to head become positive, right? So do that first, and then just think gains and losses. Gains and losses. All right. All right, so negative 47 minus 6. Okay. So can I make those two negatives positive? No, right, because they're not head to head. Right? So this is not the situation where we make the two negatives positive. They're not head to head. So none of that, right? Not two negatives. Whoops. Things a little slow in following my writing. Not two negatives next to each other. Come on. Makes me write so slow. Okay, so it's not two negatives next to each other. So we can't make them positive. So what do we do then? Well, we just think gains and losses. Think about the football team. That's a big loss. Think about the football team. They lost. Now don't think this way. This is where students get confused. They look there and they go, wait a minute, I guess I got to subtract, so that's 41. No, don't think that way. Don't even think adding and subtracting at first. Just think real life. Gains and losses. Math should reflect the real world. So that negative is on the 47, and that negative is on the 6. So let me say that even now. Anytime you have a sign, it's really with whoever it's in front of. I mean, I know we look at that and we go, well, it's in the middle. Sorta, it's really on the 6. That's going to be the most helpful way for you to think about signs. They're with who they're in front of. So that's how you should look at that. That's really a negative 47 and a negative 6. Think that way. Notice I have not said a word about add or subtract yet. I've just looked at their signs, given them who they go with, then I think real life, football or money. If the football team loses 47 yards, and the next play they lose 6 more, it's the Raiders without Carr, what's the result? Yeah, and you know to add them, don't you? You just smell it. I never said to you add, but you just know it. Because you're not a monkey. Monkeys don't know it. They don't think. Humans are unique. We have logic. You know it. I know animals can do animal thinking. They just imitate tricks. It's all they do. They can get some fancy tricks. But I want an animal to write a book or do some math, then I'll believe they can think. They can't. We're different. We have logic. So all I need to say to you is 47 lost, 6 lost. You know add, huh? You don't need to be told that. You know it means add, don't you? So, or money, same kind of thing. So just think gains and losses, you'll automatically know. Your logic will kick in, you will know what to do. So again, notice I did not look. The mistake people make is they right away say, well, I've got to subtract though. So is everybody hearing me on that? Don't think add and subtract first. First, identify the signs, loss of 47, loss of 6, and you'll know right away. You'll know right away what that means. Fractions can be difficult, so we need to definitely talk about them carefully and slowly. So let's do that. All right, so we have 7/5 minus 4/3. Okay, yeah, this will be the hardest problem we've done today so far. So we need to subtract those two fractions. If anybody have the Casio natural display calculator? That's a super nice one. Super nice. I mean, if you're going to buy it, don't buy it if you've already got a calculator. But if you need to buy a calculator for the course, you might just borrow it from your friend or whatever. But if you need to buy one, that's a different Casio. That'll work fine. But the Casio, if you need to buy one, I highly recommend, and I have no personal, it almost sounds like I get 10% of there. No, I don't. But the Casio Natural Display, honestly, it's so nice. They did a good job. I have 3 of them. The Casio Natural Display is so easy to use. You can just type in the fractions like this, and it'll handle it straight. It does a million other things really nicely as well. So if you need to buy one, I mean, don't. It's and it's the same price as all the rest. $12 at Target or Walmart, or $10 or whatever. Probably the bookstore has them too. Anyway, we'll do this one by hand. But if you have a Casio Natural Display, it'll just do it for you automatically, which is fine with me on the test. There'll be lots of things with X's that your calculator won't do that you'll need to do by hand on the test. But I'll do this one by hand with you. So how do we subtract fractions? Do you remember? What do you do to subtract two fractions? Common denominator, exactly. Yeah, you got to make the bottoms the same. right? And by the way, if this was times in the middle instead of subtract, then you don't need to make the bottoms the same. Are you aware of that? Do you remember those kind of rules? Multiplying is actually easier. Or dividing, you just flip the one on the right. Remember all that? We'll get to that. But for adding, subtracting, that's actually harder. You do have to go through all the tedious work of making the denominators the same. So what do? Well, you basically multiply by the other number, huh? So I'm going to multiply top and bottom of this one by the 3, the other denominator. Whoops, that didn't work out so well. And then I multiply top and bottom of this fraction by what?
5.
By 5, the other one's denominator again. So you just multiply by the other denominator. See how that'll make both denominators 15? Make the two bottoms the same, common denominator, right? So you just multiply by the other denominator. But why do I have to do it top and bottom? Why don't I just do the bottoms?
Because that would be okay.
Yeah, because otherwise I would change the fraction. Huh? We're trying to make it look different without being different. That's a lot of what we do in math. We make things look different without being different. So this will become 21/15 minus, and this one will become 4 times 5, 20, and then again 15 because it's 3 times 5. See how we made the two bottoms the same? Common denominator, right? And now you can subtract them. So 21 minus 20 is 1, and the denominator just stays, even though I can't write it. 15, doesn't it? We're done. There's our answer. Is that good? So just multiply top and bottom. You've seen that before. It's a little tedious. Make them the same. I'm going to keep moving. If you missed some of that. All right, so number 18. So 7/9 minus 6/7. So go ahead, try that one. I'll give you a minute, and then I'll finish it up. See what you can do. Remember, you got to multiply top and bottom by the other denominator, right? To make the two bottoms the same. Use your calculator. If you're rusty on some of those times tables, you know. There's calculators on everything. So you guys are multiplying the first one, top and bottom, by 7, right? The second one, top and bottom by 9. So both of them are becoming, what, 63 on the bottom? Just getting there. Feel free to check with those around on these new ones, you know, as much as you can out of our couple hours together. Feel free to compare and stuff. Is that working out? All right, I'll finish it up now. So multiply top and bottom of this one by the other denominator, 7. And top and bottom of this one by the other denominator, 9, like that. And then what do we get? So it's going to be 49/63. Use your calculator if you're rusty on some of that. 6 times 9, 54/63. Okay, and then we can subtract those, huh? What's that? Is that mine? So subtract 49, take away 54. Is that minus 5? Over, and then the bottom just stays 63, and that's it. Minus 5/63. How many got that? Raise your hand. I just want to see where you're at. Okay, most of you guys. Good. I do that every now and then, so I know whether to speed up or slow down. Looks like you're quite comfortable. Any questions I can answer on that one? Is that good? Okay. Keep moving. We're all okay. So can you all see the question well enough? So it's 22 minus 19 minus 3 minus 5. Oops. plus 7. Okay. You want to try it? Let me give you a second again. I think you get more out of it that way. So you do something first, and I'll jump in just a second. So what should be done first there? Yeah, the double negative stuff, huh? Yeah, everywhere where you've got like two negatives right next to each other, make those into positives. Yeah, so do that first. Two negatives head to head, right next to each other, make them positive. So that'd be like these two negatives are going to be positive, positive. And you can drop the parentheses. They're not really doing anything important. You could leave them on if you'd like to. They don't mean multiply, do they? Because never is there a number right up against the parentheses. There's always a symbol next to the parentheses. So those parentheses are never going to be multiplied in this problem, are they? Your parentheses only mean multiply when something's right up against them on that. And so same thing here, two negatives, positive. You can make one or two plus signs. It doesn't really matter. It's add either way. So it really becomes that, doesn't it? And I would probably just type it into my calculator from left to right. 22, add 19, subtract 3, add 5, add 7, 12, 28. Is it 50? Straight old 50, huh? Here we go. So the first thing we did is the two negatives head to head, we made positive. Two negatives head to head, we made positive. And then just do it left to right in your calculator. All right. So okay, so translate to an algebraic expression. Can you all see that? 17 less than t. 17 less than t. So how do we write that in the language of algebra?
T minus 17?
Is it t minus 17?
Yes.
Or is it 17 minus t?
No.
How do you know? Does it matter? Or are they both good? Yeah, the one when you're right. You guys are totally good. You're totally right. Yeah, it's really an English thing. The English words less than means that thing goes at the back. Huh? Think about you know what? I think the easiest way to know that's true. What if it said 17 less than? So what's the rule on multiplying when you got negatives and positives and stuff? So I've got negative 20 and negative 10. Now those are multiplied, aren't they? Parentheses do mean multiply this time. How do we know? Because they're right up against each other, no symbol in the middle, huh? If there was like a plus sign or something in the middle there, then they would not mean multiply. They would be add, subtract, huh? But there's not. So these do mean multiply on this one. So, okay. Is the answer going to be positive or negative? Yeah, you know the rule. Oops, I can't write it. I can say it better than I can write it. 2 negatives multiplied equal positive, don't they? So it's going to be positive or regular 200. Use your calculator if you need to. So you don't even need the plus sign. I'm just emphasizing it. It's just a regular 200, isn't it? All it is. So 2 negatives make positive. That you already know. It's really all you need to know, which you already knew for this section. All right, so we have 4 ninths times negative 5 halves. All right, so what, first off, is this answer going to come out positive or negative in the end? Negative, because the positive times the negative, huh? Right, so it's going to be negative something or other. We know that much. I'll put that down. Now, what's the deal? What's the rule when you multiply fractions? Yeah, there's a couple of ways. Probably what I'll do is just show you right now, and then I don't think we're going to, I didn't realize there were these, so we won't finish this section. But let me show you once, and then we'll pick it up again on Wednesday. But yeah, there's two things you can do. You can go straight, top with top and bottom with bottom straight, and then reduce afterwards. Or you can cross-cancel right now, which really is effectively early reduction instead of late reduction. It'll work either way. Let me show both ways, and we'll be done. So if I go, let me bring it, I'll bring it down. If I go straight, 4 times 5, 20 on the top, and then 9 times 2, denominator times denominator, 18 on the bottom. But then you see I've got to reduce that fraction, huh? I can't leave it that way. That can't be my final answer. Whenever you can divide something out of the top and the bottom of the fraction, you must do it, right? What goes into both of those? 2, huh? So I'll go divide by 2, and my final answer is negative, 10/9. And it's totally okay to leave the top bigger. We have no problem with that. The only thing we can't do is leave it where something could have been divided out. So negative 10/9 is our answer. Now the other way, just one second. The other way that we could have done, let me redo it over here. So I'm going to redo and take 4/9 times negative 5/2. And this time, I'm going to do the cross-cancel thing. So that's a little quicker. You don't have to, though. It'll work either way. So I'm going to go 2 goes into 4 2 times. And they're both gone, right? I canceled the 2, canceled the 4. They're gone. They're not there anymore. When 2 goes into 4 2 times, or 4 divided by 2 is 2. Now, if the bigger number had been on the bottom, if the 4 had been on the bottom, then the leftover 2 would have been on the bottom. The leftover is wherever the bigger is, huh? And then whatever's left over, now you go straight. So 2 times 5 straight is 10. It's negative, of course. And the bottom, 9 times nothing is 9. Same answer in the end. And a little easier on the numbers, I think, to do the cross-canceling. So cross-canceling is just early simplification. Question? Comment?
You don't have to turn it into an expression using like that?
Yeah, oh yeah, good question. Yeah, it's totally fine to leave the top bigger. You don't have to make it improper. The only thing we can't do is leave it where it can be divided. But yeah, top bigger is fine. Just leave it that way. Yeah?
So to clarify, when we look at the tentative schedule on the syllabus, let's say, so our homework tonight is
Yeah.
1.1 through 1.6.
Yeah, let me be extra clear on that. Exactly right. So the homework due on Wednesday. So the homework due Wednesday at class time, 11 a.m. is MathXL, the mathxl.com thing. That'll be 1.1, 1.2, 1.3, and 1.4. Not 1.5. We didn't finish 1.5. But we finished 1.1 through 1.4. Those will all be due, meaning you get them all right eventually through as many tries as it takes by 11 o'clock. Now you can do it late. Yeah, let me mention late. You can do late homework, but it's half credit. So MathXL lets you do it, and you can do this homework on the last day of class. That's fine, but it's half credit. Any homework you do late is half credit. It tells me the date on my screen when I go in and look at the 2 grades. So as long as you have it all done by 11 o'clock on Wednesday, all those sections, you get full credit for it. Other questions on the MathXL? Yeah, I believe it goes on cell phones. Yeah, there is an app. Yeah, it works on all different platforms. Other questions on all good? All right, so those that needed to add, come on up, I got ad cards. Otherwise, I'll see you guys Wednesday. Purchase that MathXL by Wednesday. Have a good day. Welcome back to school. Yeah. You're right. Yeah, you don't even know the fancy word there. I'm impressed. Yeah, it's because of the associative property, or it's actually not associative, it's the commutative property, but yeah. Yeah, 30 increased by b. That means 30 plus b, or you could actually do it either way, because the order of adding doesn't matter, huh? Subtraction mattered, like the last problem. It matters what order you have to, right? Because 10 minus 3 is not the same as 3 take away 10. Can't take 10 from 3. So subtraction matters, but adding, 10 plus 3, 3 plus 10, whatever, it's 13 either way. So it doesn't matter which order you type this in, it's good either way. So adding, we don't ever worry about the order. Subtraction, we have to be more careful on who goes in the front and back. All right. Okay, so let's try this one. Okay, so 1 more than 4 times a number. 1 more than 4 times a number. So, trying to get it straight there. 1 more than 4 times a number. So how do we do that? 1 added. Yeah, and what do they want me to do for number? They want me to use x. Can you see that right there? They're saying use x for the variable. So 1 more than 4 times x is what we want on that.
And you could write it for x plus 1 as well.
Good, exactly right. Because again, the order of adding doesn't matter, huh? Yeah, either one's right. Yeah, type in either one, it's good. 1 more than 4 times x. Either order. Good? Mostly familiar to you? Mostly review, I think. Okay, so, all right, 2 less than a product of 2 numbers. 2 less than a product of 2 numbers. All right, you want to try that in your own paper? Let me give you a second. Try that first, then I'll finish that. 2 less. What does product mean? Multiply. Product means multiply. It's a result of multiply. Yeah. So go ahead and try it in your own paper. 2 less. And the letters they want you to use are x and y. Everybody knows that? Right up here. Use x and y, because we're talking about 2 numbers this time, right? So x, 2 letters we need, x and y. So 2 less, where does that 2 go? Remember what we just learned about when they say less? Where does that 2 go? At the back. That minus 2 is at the back, isn't it? It's not in the front. That's the very meaning of the English phrase less than. Right? 2 taken away at the back. So we know there's a minus 2 at the back. Whoops, it's not a 2. We know there's a minus 2 at the back. So what goes in the front? The product of 2 numbers. What's the product? X, y. Nothing in the middle because that means times. Huh? So there we go. XY minus 2. That's 2 taken away from, 2 less than, the product of 2 numbers. Is that good? Making sense? All right. Okay, so your salary after a 5% salary increase, if your salary before the increase was S, can you see that little S there? All right, so how do you increase something 5%? Yeah, like what if I said, hey, there's a $100 reward for turning in somebody, whoever drove up on, there's somebody that drove up on campus last Thursday. It was funny. I don't know if you saw, did you see it in the news or whatever? It was the teacher welcome back day. Last Thursday we had all of us teachers got together and did the first day rah 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 kind of thing. They do the first day of every semester anyway. So, and in the middle of the day there was a car chase. Somebody was driving a stolen car and they drove onto the campus, right next to the science building. The chopper was following them and the police cornered them right there. Anyway, it's kind of funny. So, what if there was a $100 reward? They got him, whoever that was. They pulled him out of the car. So, $100 reward. And then somebody said, no, we're going to increase it 5%. How do you increase? What would I do to increase that 5%? Yeah, you would go times 0.05. And why the 0.05? Well, because 5%, when you change to decimal, is 0.05. Is everybody aware of that? Because you ever notice the percent symbol has 2 zeros in it? That tells you to take the decimal back 2 places, doesn't it? That's what the 2 zeros in the percent symbol mean. They mean the decimal, which was really understood to be in front of the 5, needs to go back 1, and it's back of the 5, 2, and that brings in a 0, doesn't it? 0.05. So when you change the percentage to a decimal, it becomes 0.05, and you need to multiply. But that's not all. Think with me for a second. If I did that, you guys have a calculator, you would just get 5, wouldn't you? So we're saying you increase a $100 reward 5%, and it becomes $5. That's not a very good increase. Then we got to add back the original. It's not just multiply by 0.05. Then add the 100 original. Right. Okay. So with that thinking, we think better with numbers than we do with letters. That's why I just did that with numbers. We all thought it out. The final answer would be 105. That's the increase. That's the new amount, right? So let's do that same thing now. Instead of with 100, let's do it with S. So let's do with S what we did with 100. Well, what did I do with 100? Right here, I took 100 times 0.05. So I'm going to take 0.05 times S. I put S on the right side. You can put it on the left side. The order of multiplying doesn't matter, right? 2 times 3, 3 times 2, 6, either way you do it. 0.05S or S 0.05. That means 0.05 times S. Remember, S is playing the role of the 100. S is the original salary, which we're going to increase 5%. So just like I took the 100 and I went times 0.05, but that's not the whole answer. That would just be the $5. That would just be the increase amount. I've got to find the new, larger amount with the increase added. So what do I got to do now? Got to add the S. That's my answer. Well, almost. I could do one other thing. But does that make sense? Do you see how I'm doing with the S exactly what we did with the 100 there? Do you see that? Right? What did we do with the 100? We times it by 0.05, and then we added back the original 100. So with the S, I times it by 0.05 and added back the original S. Because that's the original salary. This is the increase, the 5% increase. That makes sense? So the mistake is people forget to add back the original. Now, can I clean that up? Can I simplify that? You probably know the answer is yes. That's why I said we're not quite done. How do I simplify that? What do I do?
0.5.
No. Think with me for a second. What is like, say, 2x plus, you guys know a little algebra. What's 2x plus 3x? 5x, right? You just, it's not 5x squared, by the way. We'll get into all that in weeks to come. But why is it not x squared? When do you make x squared? When does that kind of thing happen? When you're multiplying. Yeah, we'll get into that later. We're not doing that right now. When you add, you just add the numbers. You keep the x's plain old x. Right? You know that, right? You remember that rule? Well, so that means when you have two letters the same, like S and S or X and X, you need to add the numbers in the front. Combine like terms, that's called, right? You've heard that before. Well, what number's in front of that second S? I don't see any number there.
1.
It's 1. There's an understood invisible 1 there, really. Because 1 times S, that's the same as S. Right? So now we add those two numbers. Now, just like we add the 2 and the 3 to be 5 for X, we add the 0.05 and the 1 to be 1.05 S. Whoops. It's not coming out. And that's our final answer. 1.05 S. Does that make sense? What that means, do you realize what that means? That means if you have a salary or an amount, like say $100, instead of multiplying by 0.05 like I did right here, right? I multiplied by 0.05, got the $5, and added back the original 100 and got the 105. You could do it in one step. You can do this anytime you want to buy something with tax and you want to know the price. I tell this to people every now and then, clerks, and when I see them doing it in 2 steps, I say, guys, just throw a 1 in the front. You can do it in 1 step. Now, instead of multiplying by 0.05, getting an answer and then adding back the original, you can just multiply by 1.05. See, the 1 gives you the original. 1 times anything is itself. And the 0.05 gives you the increase, gives you the whole thing all at once. Do you know what I mean? Am I making any sense? So, for example, if you wanted to take the $100, that's a little formula, if is what I'm saying. So, if you wanted to take the $100, let me erase this little X thing I was doing. Let me take that little formula, and suppose I said I want to take the $100 and increase it 5%. Well, just multiply by 1.05. Instead of multiplying by 0.05 and then adding back the original, all these steps I did over here, one step, that'll go straight to 105. The final answer, and you're done. Do you see that? That's the way to, if you're looking at something on Amazon or whatever, and you wonder what the price is going to be with tax, or you just multiply by 1 point whatever the tax is. It gives you the whole final increase in everything all at once, is what that does. Is that good? I always remember, I used to work different, when I was going to college, I would always have a summer job in between classes. So in the summer, one summer, my last summer before I finished my master's degree, I worked at PG&E. I was in Powell, San Luis Obispo area. I got a summer job my last summer before I finished at PG&E. I took their bill payments. I was in their office. I was one of those clerks that just took the money for people that came in. Anyway, I remember telling the other clerks, we were all doing these calculations all the time. We're having to do people's percentage. And I remember telling the other clerks, hey guys, we don't need to do this in 2 steps. Instead of multiplying by the percentage and then writing that down and then adding back the original and getting the new total, I said, just throw a 1 in the front. Just throw a 1 in the front, you do it in 1 step. And I showed them. I said, see here? I threw the 1 in front. I remember it's kind of funny. Because I was like the college kid, right? All the rest of them, that was their full-time career. That was what they did all the time. I was just a college kid in there for the summer, going back to finish my master's degree afterwards. And I remember when I showed them that thing, they were like, oh, whoa, I don't know what you just did there. That's one of them college tricks. And I can't trust that trick. I'm not doing it that way. I'm like, okay. I mean, they thought I was doing like magic. I felt like I was a magician or something. Anyway, so I was regarded as the college kid. Okay, but anyway, it's a simple truth of mathematics. Just put the 1 in the front. All right. So what does that mean when they say it lies below the ocean? How do I do the number? Yeah, all they want you to do is say negative. See, this one is 35,800 feet below sea level, the deepest point in the Pacific Ocean. So they just basically want you to enter negative 35,800. That's all. They're just making sure you know that's negative, right? Below is negative. That's all they want. Type in negative 35,800. So let's do that. Okay, so they're giving me 17/4. Everybody see that okay? 17/4, and they want me to graph that on the number line. How do I take a weird old fraction like that? 17/4. I mean, where does that go on the number line? You know what you should do with that 17/4? What's that? Yeah, you could do that. I would just use my calculator and divide. But yeah, what you're saying is true also. I would just simply, on my calculator, take 17, divide, because a fraction means divide, right? And your calculator will tell you something. 4.25, is that what it is? Yeah, 4.25. Just turn it into a decimal, right? If you just divide the fraction on your calculator, it'll become a decimal. That's the same as 4 1/4, like you were saying. If you wanted to, whoops, getting off there. 4 1/4, if you wanted to make it into an improper. Either one of those is fine. There are 2 ways to say the same thing, aren't they? And either way, where does it go then? Well, yeah, a little bit past the, whoops, what am I doing? Just doing something weird. A little bit past the 4, right about right there, huh? And they'll give you options. I don't remember exactly how it works. I'll go back and show you actually in a second. But they'll give you different positions, and it's a little bit past 4 is where you need to click. Does that make sense how I turned that into a decimal that we're more familiar with? Just divide it on your calculator. All right, so negative 6/17. They want me to turn that into a decimal. So take your calculator again. Take 6 divided by 17. I have no idea what that is. Somebody have that? It's 0 point something or other. 4, maybe 3.
0.352.
3, 5, 2, and on it goes. Yeah, that's good. Whoops, I can't get the 2 there. 3, 5, 2, and dot, dot, dot. Okay, so now they say round to the nearest hundredth. See the little message there? That's exactly what you'll see on Math Excel. Which spot's the hundredth spot? Do you remember? Yeah, this first one after the decimal is the tenths. It starts. The next one's the hundredths. That's the one they're talking about. So how do you round? Well, you circle the spot they want you to stop in. They want you to stop 2 places to the right, hundredth place, if you remember the way the place values go. And then that means you look 1 to the right of where you're going to stop. So I'm going to stop at the second spot, circle that, look 1 to the right. If the 1 to the right is 5 or more, you go up. If it's less, you leave it. So we're just going to leave it, right? So it's going to be 0.35, and we're done. Does that make sense? Round to the hundredths. Just remember the place values there.